All right, 7.4, so our last set of notes for Chapter 7. We're going to transition from what we did in 7.2 and 7.3 and performing hypothesis tests for population means to now performing hypothesis test for proportions. Okay. And so hypothesis tests for proportions can be used in a lot of ways. Popular one is politicians want to know about proportion of the constituents who favor a certain bill. Now, there are 6 steps to proportion testing. And a lot of these we've done in the past. So we want to verify NP is greater than or equal to 5 and NQ is greater than or equal to 5. We've done that. We want to state the hypotheses and identify the claim. We've done that in this chapter already. We want to compute the test score, so our z-score. This is similar to what we've done previously with the means. We just have proportions now, okay, or a one proportion z-test. We want to find our p-value, and again, we're going to end up doing that in Staplet or our table. And then we'll make our decision to reject or not reject, just like we were doing earlier in this chapter, and then we summarize those results. All right, so let's just jump into our first example. I think it's the best way to learn this information. So a researcher claims that less than 45% of U.S. adults use passwords that are less secure because complicated ones are too hard to remember. In a random sample of 100 adults, 41 say they use passwords that are less secure because complicated ones are too hard. At an alpha of 0.01, is there enough evidence to support the researcher's claim? All right, so we're going to go through our step process here. All right, so step 1, we want to verify NP is greater than or equal to 5 and NQ is greater than or equal to 5. All right, so to do that, let's identify our parts that we have. So we're going to need our N, we'll need our P, we'll need our Q. All right, we're going to have our P hat in here as well. All right, so we're given our N is 100. Our P is 45, or 0.45. Our Q now is 1 minus that. So 0.55. And then our P hat was given to us as our sample there. All right, so let's plug in those pieces of information. So our N is 100 times our P, which is 0.45. And then 100 times our Q, which is 0.55. So that's 45 is greater than or equal to 5. 55 is greater than or equal to 5. So 1 checks. HO is P is going to be greater than and equal to 45. And they want to claim less than 45. So remember, the less than, since it's not equals to, becomes our HA. And then those two are always the opposite of each other. And as I said, that's our claim. So our HA becomes our claim. And since we are less than solely, this is a left-tailed test. All right, and 2 is good. All right, so now let's look at 3. So that's going to be our formula over here. I'm going to find Z. So P hat minus P over the square root of PQ over N. So 0.41 minus 0.45. 0.45 times 0.55 all over 100, and that is about equivalent to negative 0.80. So that works. All right, 4, find P. All right, so we're looking at our sketch here, and so we have a Z of negative 0.8, and we want less than, so we're looking for that. So then we can go to Staplet, and we're looking at normal distributions, and we're looking at our P. Mean is 0, standard deviation is 1. Okay, and we are looking for to the left of negative 0.8. And so then we get an area of 21.19 or 0.2199. Okay, so now we've checked that. Now we're looking at step 5. So since our P, which equals 0.2119, is greater than our 0.01, which was our alpha, then we fail to reject our null hypothesis. All right, and then 6 is our summary. So we're going to state there is not enough evidence at the alpha level, which was 1%. To support the claim that less than 45% of adults use less secure passwords. All right, let's look at a couple more examples here. All right, number 2. So a researcher claims that more than 90% of U.S. adults have access to a smartphone. In a random sample of 150 adults, 87% say they have access to a smartphone. At an alpha of 0.01, is there enough evidence to support the researcher's claim? All right, so same process, go through all the 6 steps. We'll identify our parts that we need as well. All right, so we want to verify NP is greater than or equal to 5, and NQ is greater than or equal to 5. So let's identify those. So N equals 150, P equals 90 or 0.9, so then Q is 1 minus that, so 0.1, and our P hat is 0.87. All right, substituting those in. So we get, what, 15 is greater than or equal to 5 here, and we get 135 is greater than or equal to 5 there. Okay, so both of those check, so 1's good. All right, step 2. So we have our null and alternative hypothesis. Okay, and we are more than, so we're going to be more than 9 for our alternative, which means our null hypothesis is going to be less than or equal to 0.9. Our alternative is our claim there. And since we are more than this time, it is a right-tailed test. All right, 3. Let's find our z. All right, so p hat is 0.87 minus our p, which is 0.9. So 0.9 times 0.1 all over 150. And that is roughly equivalent to negative 1.22. All right, so 2 and 3, we're good there. All right, so 4. And to find our p, at 0, we're negative 1.22 here, but we're right-tailed, so we want that side of it. So let's take that to Staplet now. Our new value is 1.22. And we want a right-tailed test this time. Okay, so we get that there. So an area of 88.88. So since our p, which equals 0.8888, is greater than or equal to our 0.01, which is our alpha, we then fail to reject our null hypothesis. And then last, our summary. We would state there is not enough evidence at the 1% significance level we chose to support the claim that more than 90% of U.S. adults have access to a smartphone.